So this is my final presentation to conclude my work term here at Missak, and it's my journey with Missak, presented by me. So here's the overview of the presentation. I'll first start by giving you a summary of the work that I've done, the ongoing tasks that we have right now, the next steps, my reflection, any advice for my successors, feedback for you guys, and the conclusion. So to start off the summary of my work, I'll divide it into categories. I'll first give you the mechanical work, the electrical, the software, and then the miscellaneous. And then I'll explain each task by giving you the vision, the execution, any issues that came up, the solution that I found, and the result. So we have, first up, my first task here at Missak was the acrylic display box. So the vision was to create a display to attract any future customers and investors so that they could potentially buy the product. As you can see here, this is the old product, it's the alpha, not the beta. So the execution was that I used the laser cutter in the lab to cut out the panels from acrylic. And some issues that we had was it was my first time laser cutting, so the hinges were cut off a bit. And the solution that I had was to use the plates in the areas that are not weight bearing. For example, the front plate has the top hinges here cut off, so instead of having them at the bottom, I use them at the top, so that way they're not working against gravity. And the result was that it created an elegant display for the product.
Thank you.
And then next is the acrylic rings. So the vision was to constrict the opening angle of the flower mesh so that it can increase the efficiency of the dewatering inside the machine. The execution was to first laser cut out of cardboard to figure out the gradient diameters of each ring so that we have the same opening angle. No issues and no solution was found, and the result was that it constricted the flower mesh as envisioned. Next was the compost and liquid chamber prototypes. I'm not sure if you guys used this or not, but the vision was to create prototype chambers to use for testing, and the execution was to laser cut from cardboard. And the issues that we had was here at the corners of the T slots was they were too malleable, so they kept bending, so that it didn't actually hold the screw in place. And then the solution for that was to hot glue everything together. And the result was a firm and sealed chamber. This is the SLD mechanism. The vision here was to create a mechanical sub-assembly to detect the solid level inside the compost chamber. The execution was that I CAD'd the prototype for visual representation. Initially I had it so that when the solid tipped the paddle, it would hit a sensor right here, which would send a signal to the ESP. So the issue was that we couldn't have a sensor inside the chamber, and the solution was to not use the design. Instead, it was handed off to print. And then the assembled beta ID skeleton. So the vision for this was to use the prototype as feedback for size and testing, and the execution was that it was built out of laser cut acrylic and 3D printed parts. You can see here it took a long time to assemble, but finally got it. The issues was we had a lot of misaligned holes, so the solution was to drill new holes beside it or either widen the holes. And the result was that we did end up using it for feedback. And then the assembled beta compost chamber, it's sitting outside if you want to see it, but here's a picture of it anyway. So the vision was to start testing using confirmed design of the chamber so that we can have it in the beta. And then the execution was that it was built from laser cut acrylic panels and 3D printed parts, also a metal shaft here. The issues that we had were too many. We had misaligned holes, warped prints, insufficient brackets for the pedals, and insufficient screws as well. So the solution was to drill the holes and use the good paddles that we had for testing. And we ended up testing it, and my results are on Slack if you wanna see them later. This is the heatsink setup. So now that concludes the mechanical section. This is the electrical section. So the vision here was to test for conductive versus convective heating. And the execution was we had a piece of sheet metal cut out and we added resistors to the back of it so that it gets heated. The issues was that when I was coding the temperature sensor, it took a lot of time. So the solution for that was that I got help from Evgeny. And the result was the heatsink was not powerful enough, and it created mold inside, and it was very bad. Very negative result. Next was I soldered power modules and sensors for the ozone test 1 and 2. The vision was to use them for the test 1 and 2. The execution was I soldered wires to connect the modules. As you can see here, it goes from the AC-DC converter to each module, and each module has a different voltage. There were no issues that came up, so no solution was needed, and the result was that it's ready to use for test. Next was I soldered the DIY power supply components. As you can see over here, this is a diode, this is the diode, this is the regulator, and the 2 capacitors. So the vision was to get one power supply to power 2 lamps. And the execution was that I soldered the wires onto the components. Issues was it was very tricky since the components are really small, so the solution was I took my time with the soldering. We all know that saying, slow and steady wins the race. The result was solid connections between the chips and the wires, and if you try to move them, they will snap. So you can't really move them. Alright, so that concludes the electrical. Now this is the software. So this was the fan power cycling logic that we used for testing. So the vision was to power cycle the fan to reduce energy consumption and to find ideal conditions for the composting. The execution was that I added new files to perform this function. The issues were could not figure out the task creation at first, so I got help from Matthew, which, Kate, if you're listening, it was my old my old friend, who is still my member. Result: functional power cycled fan to be used for testing. Next.
Jill got nervous there.
Yes, I did. Carrot testing. So this was my responsibility for many weeks. The vision was to conduct several tests to find ideal conditions for the composting. The execution was to first set initial conditions and then modify after observing each result. There were no issues and no solution was needed, and the result was most tests yielded negative results, as you can see here. If you try to open these containers, you will have a very bad day. And no ideal conditions were identified really, since the only positive result was we had was dry compost. So this is the ozone versus oxygen test. We're now in the miscellaneous section. As you can see here, we have the ozone lamp over here in the air inlet. So this takes in the air with the ozone and then kills the odor inside by blowing it in the chamber. So the vision was to observe any changes to compost with the presence of the ozone, and the execution was to add the ozone here, as I said before. The issues that we had was the chambers kept popping out, and the solution was to temporarily hold the chambers in place with duct tape, but that also did not work. They kept popping out. And the result was the ozone was actually found to eliminate the opportunity for molding and the odor inside the chamber, since no flies came out of the ozone chamber. Again, my results are on Slack if you want to look at them later. Alright, so that concludes the summary of my work. I could have kept going, but we would have never left this room. So this is the ongoing work and next steps. So we have the ozone elimination test, the assembly of the second compost chamber, which I should be able to finish today, the assembly of the frame to hold the chambers and the motors, the repetition of the ozone versus oxygen test, and the assembly of the CMF unit. And now we'll start my reflection. So I'll discuss the key learnings that I had with my time here, the identified strengths and weaknesses, and my future co-op ventures. So the key learnings. I received a better understanding of the design process, a better understanding of machining tolerances while I was building the compost chamber. Lots of things went wrong. A better understanding of Internet of Things applications when I was working with the fan power cycling logic. The use of the machinery, such as the laser cutter, the 3D printer, the power analyzer, and many other machines. And I learned to use the right tool for the job. For example, you cannot cut acrylic with a box cutter. You have to use a plastic cutter. That's it. Next. And this is my identified strengths and weaknesses. Over here you have my strengths. So I think critical thinking, the fact that I am adept, and my dedication dedication are my top 3 strengths, and my weaknesses are communication, attention to detail, and seizing opportunities. For example, my critical thinking I think is very strong because whenever I'm faced with a problem, I usually tackle the pros and cons of it and try to find multiple solutions and then decide on the best solution. And me being adept, that is to say that I'm a fast learner. I'm not sure if you guys noticed, but I don't have too much knowledge, but I make up for it by learning things quick. And I have dedication, which is I just can't leave a task unfinished until I finish it and see it to the end. And then for my weaknesses, I think I improved my communication. Usually I wouldn't be able to present very well, but I think I'm doing better, as you can see right now. My attention to detail, this is the example of me taking 6 hours to cut acrylic. It took a very long time, but hopefully I'll look out for it in the future. And then seizing opportunities, I could have learned much more from all you talented engineers here, but unfortunately, I don't seize opportunities. So future co-op ventures. So before I started applying to any co-ops, I had a very specific job description in my mind, which is I wanted to work with a device of the mechanical section, the electrical section, and the software section. I didn't know that there was a specific position for it, but I found out that it's called embedded engineering. So I can see myself having a career in embedded engineering in the future. But before that, before I decide on a career path, I want to try a software position, maybe an electrical position, and an electromechanical position. And the job market is pretty rough right now, so if you know anyone looking to hire in the fall, please connect me. So this is my advice for the successors to ensure success in this role. Number 1, be vigilant in your work. Things can pile up very quickly here. One week you can have nothing to do, and then the next week you're putting overnights every day. So make sure you complete everything as early as you can. And at the start of each day, set your priorities. It's very important to be able to know what to work on first and what to get done. And if there's something easy that you can finish right now, it's better to work on that than work on something hard that's going to take you like a week or so. And then third is, when in doubt, ask for help. I didn't really take advantage of this much because I like to see things through my own way. But whenever you are stranded against a wall, try to see if you can escape from it by asking someone for help. So this is my feedback for Missak. So, number 1, I love the work environment. I also love the learning opportunities that I had and the feedback that I got from my colleagues. The only thing that I would have changed was to be involved more with the design of the product, because when I was getting explained things to me about the product, such as CMF or ID, I was getting lost. So if I was more involved with the design, I would have understood what you guys were trying to tell me and envision it in my head. And then this is the conclusion of the presentation. So I completed lots of significant work. I learned a lot about the product design and optimization. I identified new weaknesses to strengthen, and this concludes my journey with Missak. Thanks for listening. Pleasure getting to work with you all. Good luck on your product launch. I'll be waiting for an invite in the mail.
Very good, thanks, Joe. Any questions for Joe? Any feedbacks? Anything anybody wants to say? Please stand a little closer. Who spent the most time working with Joe?
I think I spent quite a lot of time with him.
So what do you guys think?
I think, from my opinion, like, he's a really nice person to work with. You are a really nice person to work with since you're still here. So some feedback from me to you is that, sometimes, goods and bads, so both, right? So you are really committed, so that's a really good thing, as you said. You pay attention to details as well. So sometimes when I want to get some things done, you come up with new other solutions. That's good. It's not just my solution. You think in your own way can work. It's good. So those are good things. There are many good things as well.
Don't give me negative feedback.
Yeah, so I just realized, some negative feedback, but it's not a bad way, it's not a bad thing, but sometimes when I try to explain things to you, maybe that's the way of, engineering practice from my experience and stuff. You might, maybe tell me it can be done like this as well, but sometimes I'm telling you because it's the right way to do it, or maybe, so maybe if you can just grab it, and then it doesn't have to be like that, but you can actually try. But you did actually that, sometimes that's why I said, you're a fast learner sometimes. I tell you, this is how it's supposed to be done, and then next time I see you, I'm sometimes just watching you doing stuff. You're actually doing it the way I actually told you to do it, so it's good. So yeah, keep doing that, and you can learn a lot. Try to learn from as many people as possible. So because they're still growing. I mean, I'm trying to learn from others as well. So we are all learning. So yeah, keep doing good.
Okay, thank you.
Yeah, thanks. Nice work with you.
That's Harn, the mechanical lead. Now let's hear from Jenny, the electrical lead and software. Just a few words. It's good. No? Thumbs up, maybe?
I left them speechless.
Okay, if Jenny gave a thumbs up. Anybody else? Maybe.
It was my pleasure to work with Justin. Whatever I expected always happened, so
Thank you.
very, very, very positive about work and getting things done. I didn't interact too much, but this is my impression.
Yeah, I have a few things. I mean, I really enjoyed the very small period of time knowing Joseph. I mean, I came here literally last Friday, and then we were assigned to do a job, give me the PDF version of the design. And from Joseph, I can see the company. It's actually, I just think about the word organic. It's really helping the new graduate student for internship, co-op, helping this is from social standpoint. It's really beneficial. Everybody, putting the strength and effort into developing something new or create something organically. And I think it's very, very nice. And the other thing is, I mean, I'm not engineering, but I work with engineering people all the time. And my suggestion to you is, engineers tend to be doing things very, straight to the book, which is, it has to be that way in a certain sense. But never forget, we design things for people. Understanding people's needs is always important. Whenever you get a task, I always know, if I'm not clear first, but I tend to repeat what your expectations are, and I'll communicate back. At least we set expectations first. Then we work around expectations, sort of you get a scope of work. And then when you clearly communicate what you can capable do, and maybe they can give suggestion, help, then will help both parties getting things done more efficiently. And I appreciate you get back to me on Saturday morning, and you cannot finish your I call you, you call me, whatever. But that's how, in an environment like this, you never have a standard. There's no rules. Just because we're a startup, we're still preparing phase for just for the prototype. So there's no rules, but whenever you communicate back and forth, it could help making things more efficient.
Okay. Good. Thank you for the feedback.
Likewise.
Good. If nobody else says, I'll say something. I've been working with Joe since the beginning. We have monthly, if not bi-weekly, reflection meetings. So basically mentoring for the 4 month, right? I see Joe growing a lot, both on engineering aptitudes, but also, the soft communications. You say you cannot do it, but it's doing very well. You're communicating, presenting very well. I see. Standing up right next to it. Have a good aesthetic taste as well. Yeah, picked a good product. But yeah, Joe has grown a lot, and I think you have your strength. The key thing here is not really to improve your weakness, right? That's not the top priority. Top for your personal development is really to reinforce your strength until you're the world class at it. Right. So That's why, if for the future, for your next co-op, for example, be very clear what you're good at and just keep reinforcing that strength. Okay, so those 3 things that you put down, make them better. On the weakness side, again, it's hard to improve on the weakness, and a lot of times it's not useful. As an engineer, you want to do, I'm not good at sales, I'm gonna try to improve my sales. It's not useful, and a lot of times it's just sunk cost in developing. However, what I found is if there's a weakness that you cannot live with, and you have a breakthrough, turning that weakness into a strength, it will be your super strength. Okay. So my task for you after this co-op is to think about, look at those 3 weaknesses, think about which weakness you cannot live with that you want to turn into a super strength. Okay, and just sink your effort into that weakness to get to that breakthrough until it's no longer a weakness, and then just try, and you will feel that when you reinforce it, it will be so much better than all of the other strengths, because the sky is the limit now. That's my suggestion for you. Okay, but good job. Thank you very much for the awesome term. I'll be submitting your work term evaluation on Monday. Okay. But yeah, let's do a final reflection before you leave as well.
Can you go to the first slide? I'm gonna make a cover.
Oh, okay, good idea.
Yeah, Joseph, he was, I think, very good.